Sketch the hyperbola and its asymptotes. Give the equations for the asymptotes. These are a little bit different hyperbola. Now, it's not in the typical form we see this equation, but you have seen this equation if you just divide both sides by x. You get y is equal to 4 over x. How have you graphed that in the past? Well, if x is 1, y is 4. If x is 2, y is 2. If x is 4, y is 1. You've seen that before. Hopefully you're seeing, oh, it's a rational function. Looks something like that. Remember you have an asymptote there because x cannot be 0. Likewise, since you have a 4 on top, y cannot be 0. What happens when x is negative 1? You get negative 4. When x is negative 2, y is negative 2. When x is negative 4, y is negative 1. Again, your rational function on the other side would look like that. Okay, it's going closer and closer to the asymptote. Now imagine you just kind of tilt your paper. I can't do it on the screen right now, but imagine you just tilt your paper 45 degrees. You'll notice that you do have a hyperbola. You can basically see that the asymptotes, they do form like your rectangle, but it's now going to be at an angle like that. Okay. All right, let's go on to number 4. Sketch the graphs, and then determine algebraically where they intersect. All right, let's do our hyperbola in green. Y squared minus x squared equals 94. What does that mean? Divide both sides by 94. So y squared over 94 minus x squared over 94 equals 1. What is the square root of 94? Because we really want that as an a or b value. Square root of 94 is a value of about 9.695. Okay, so pretty close to 10, just slightly less than 10. All right, so on the coordinate plane, let's go ahead and draw that. That is a pretty spaced out hyperbola. So I'll try my best with this. Oops, that's bad. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay. Now, keep in mind that the 9.695, that's going to represent both the rise and the run of your asymptotes. So I'll go ahead and go up 9.6 something, 9.69, and then go over 9.69, right around there. Okay, do the same thing on all sides. Right around there. I hope that's accurate. All right. So with that, let's go ahead and draw the dotted lines. There's your asymptotes. There we go. What kind of hyperbola do we have? It's y squared minus x squared. Y squared comes first, meaning we have a vertical hyperbola. So here we are, drawing your hyperbola vertically. Oops, that was bad. Like that. All right, and then lastly, we can graph x minus y equals 3. What is that? What is x minus y equals 3? Let's do that in blue. That is the equivalent to y is equal to x minus 3. Okay, so that means we go to the 1, 2, 3, the y-intercept of negative 3. It has a slope of 1, and so that means that, oh, it's actually parallel with our asymptote. It's actually parallel, right? So if it's parallel, what does that mean? Well, if you look at the graph, hopefully what you see is that the graph will intersect at one location right there. We gotta find what that location is. All right, so let's solve algebraically. How are we gonna do that? Let's do a system of equations where we use substitution again. Since y is equal to x minus 3, let's plug that into the y. X minus 3, quantity squared, minus x squared equals 94. So we're just plugging this line into the y value there, into the hyperbola. We get x squared minus 6x plus 9 minus x squared equals 94. X squareds cancel out. You're left with negative 6x. Let's move the 9 over. We get 85. So x is 85 over negative 6. Okay, so if we have that x value, let's go ahead and find the y value now. Since y is equal to x minus 3, we have negative 85 over 6 minus 3. Let's get common denominators, so that'll be the same as 18 over 6. Negative 85 minus 18, that'll give us negative 103 over 6. Okay, so what we have then is the ordered pair, negative 85 over 6, negative 103 over 6. Okay, just to verify, what are those equivalent to? About negative 14.16 and negative 17.16. That's what it would be about. And you do see that that point has gone a lot further than the negative 11, and it's also gone down down below as well. Okay, so that does check out. Let's now take a look at one last hyperbola problem. Let's take a look at number 7 here. Sketch the hyperbola, find the coordinates of the vertices and foci, and equations of the asymptote. Let's see, this is a y squared minus x squared type of graph. What does that mean? Oh, that means that we have a vertical hyperbola, since y comes first. Okay, so if that means that y comes first, I also know that my asymptote will be somewhat in the form of a rise of 16, so that's going to be a rise of 4 and a run of 3. So this is somewhat what my asymptote may look like, but I know it's not going to be the case because I do see that there are transformations taking place here. Okay, all right. Let's go ahead and take a look at this problem now. So first thing I want to do is actually draw my coordinate plane. We have, let's see, 1, 2, let's see, what are we doing here? The y is 5, so we're actually going to go down 5. That'll be where the center is. That's actually the center right now. Like that. Let's see how that goes. I think that should be enough. All right, so we know that the center being at plus 5 along the y, that tells us that the center is going to be at 0, negative 5, because the x has not moved at all. Okay, and then now we need to find the rectangle, the asymptotes. Okay, so remember that your slope is 4 over 3, so we're going to go up 4, 1, 2, 3, 4 over 3. Put a point. Do the same thing on the other side. Put a point. Go down 1, 2, 3, 4. Go over 1, 2, 3. Put a point. 1, 2, 3. Put a point. And then from there, draw your rectangle. Remember that the asymptote should cross the center. Just like that. Just like that. Okay, and then we also know that because it is y squared minus x squared, we know it's going to be a vertical hyperbola. So from the rectangle, here it is. What is that point? That is going to have a vertex at the point 0, negative 1. Oops, I should actually make that plural, vertices. All right, 0, negative 1. My other vertex is at 1, 2, 3, 4, 5, 6, 7, 8, 9 at negative 0, negative 9. Okay? All right, and then from there we can draw our hyperbola. It is vertical, so it's going up towards these asymptotes. Over here as well. And I do have space. Going towards the asymptotes. Okay. And then we need to also find the foci. Remember, the foci can be found using c squared equals a squared plus b squared. So that'll be 16 plus 9. That'll give us a value of 25, or basically c is 5. Which means from the center, we go 1, 2, 3, 4, 5. Oh, where's that? That's actually at the point 0, 0. And we also go down from the center, 1, 2, 3, 4, 5. That'll be at the point 0, negative 10. Okay. And then I believe we need one more thing. We need to find the equations of the asymptotes. Asymptotes. Okay, so remember that your general asymptote was in the form of y equals, we know that the slope was 4 over 3x, so plus minus 4 over 3x, but that's if you didn't have any shifts at all. How do we shift? We shifted the y value, all of the asymptotes, down by 5. So y plus 5 is equal to plus minus 4 over 3x, or if you move that 5 over, another way you can say that is plus minus 4 over 3x minus 5. And you can see how that asymptote actually checks out. You basically have a line that has shifted down by 5. Okay, so you have all of your information you need for this problem now. And that's it.